Welcome. My name is Mr. Moss, and I am the discrete math teacher here at Butler High School. A lot of people are always curious, what is discrete math? And I give them a couple of explanations. The first one I say, well, it's the kind of math you need to know if you live on discrete. But no, it's not really. Actually, discrete math is a math of problem solving. It's real world application. I've been teaching here at Butler High School for 18 years, and this is my absolute favorite math class to teach. Kids are always asking, when are we ever going to use this stuff that we learn in math? Why do we have to learn it? Well, this class answers that question. We solve real world problems that are important, that make our life easier and smoother and faster, that allow us to have more time to spend with our friends, family, loved ones, and hopefully have a little bit more money in our pockets as well. And that's always a good thing. Plus, there's application. So I always start off with kind of like this first problem, like, hey, I lost my glasses. Well, where are they? We use statements that you look at in life, things called like contrapositives, converses, inverses. If I switch statements, well, is it true if I say it backwards? Is that the same thing as saying it forwards? Well, what about if I take these statements and say, well, I wasn't doing that? Okay. And you can use these things to help you solve problems. And that's one of the things they do in courts of law. They're able to rule out suspects because they can say that, well, this person wasn't where the crime happened at the time. So that person obviously didn't commit the crime. We also look at things in discrete. We look at like this circuit, for instance. Hey, if these are the symbols and here is electrical current, well, is this light bulb on? Well, I need to know that so I can see to do my math homework. All right. Then, for instance, here, this is a map. And very often in life, we don't see maps that are black and white. They have colors. Well, we look at maps in this class and we try to figure out, well, can I color North and South Carolina the same colors? Well, no, I actually can't, because if I colored them the same color, well, I wouldn't be able to tell where North Carolina started and South Carolina ended. So no, they can't be colored the same color. Well, all right, so I'm going to have to use more than one color to color this map. How many colors would I need to color it? And what's the fewest number of colors? Because we know that colors and materials cost money, and we want to cut down on those expenses, especially with everything going up in the world. All right. Then we look at other word problems and things like this nature. Like if you go to a pizza place or maybe a restaurant that's offering a lot of different options, we're America. We love choices. Well, how many different choices are there? How many different meals could I create? We look at scenarios like that. Then we do a unit on set theory where we put people in little boxes and we say, okay, well, how many people are taking theater? Is that everybody? Or there some people that are taking chorus and theater? I have a lot of students that when they do the arts classes, they might be chorus and theater. Well, not me. I couldn't sing very well, but I did do some theater classes. So I would go just over here in this box. All right. Then we also look at graphs like this, and you're probably thinking, well, that just looks like a gaggle of lines. Well, it is. But if you're thinking about electricity, you don't want your lines to cross because it might short out the appliance that you're using. So just like in Ghostbusters, when they said don't cross the streams, here, we don't want these lines to cross. And you know what? It actually redraw this graph where those lines don't cross. Those are some of the things that we look in discrete at. All right. And then if we move over here, we look at coding. Okay. We might take messages in discrete and we'll use matrices to turn those messages into just a gaggle of numbers to where somebody, if they found those numbers, they wouldn't be able to tell what they were talking about. You might be thinking, well, how does that work in our real life? Well, with data encryption on our cell phones and our banking apps, we want data to be encrypted. And they use things like matrices to encrypt the personal financial information so that bad people don't steal our money. All right. We also look at graphs and we try to figure out, okay, well, what's the quickest way to get from the start to the end? Well, I could go this way. Okay, well, all right. Then what's the fastest way I can get the whole project done? We look at projects and try to minimize and maximize things. All right. And then lastly, we'll end up here with this. This just looks like a old chart. Well, this is a scheduling problem. and I get all of these clubs scheduled during the week. All right. And then what's the fewest number of days required to do all that scheduling? All right. So those are just some various things that we look at in Discrete. It's a really fun class. It really answers that question. When am I ever going to use this math? Well, the thing is, you use math all the time, every day. And this class exposes you to that. And I oftentimes tell my students, if you can figure out how math works in the real world, it's going to help you with time. It's going to help you with money. All right. And those are things that are very important to us, especially as we get older and we have less time with responsibilities in our life and we need money to be able to eat and provide for our families. And that's what we want to do, have good families, good relationships. So if that sounds like something you're interested in, I would love to have you in discrete mathematics. My name's Mr. Moss. Y'all take care. Thanks for watching.